Good evening. Today's topic is probability. Actually, you had done probability in 10th standard also, but in 11th standard, we again start with basic things. First, we define or we discuss few terminologies like random experiment, outcome, sample space, etc. Then we define probability and so on. So the first concept is that of random experiment. Any act, ACT act, any act or any act or a phenomenon, I can say, any act or a phenomenon which can be performed number of times, any act or phenomenon which can be performed number of times, which has more than one possible results known in advance, but it is impossible to predict which one is going to occur, then that experiment is called as random experiment. I repeat this, any act or phenomenon which has more than one possible results known in advance, but it is impossible to predict which one is going to occur is called as random experiment. For example, if we throw a die, what is die? Die is a cube on six faces of which numbers 1, 2, 3, 4, 5, 6 are written. Singular is die and plural is dice. Okay. Now, can we throw a die number of times? Yes, we can. Do we know possible results in advance? Yes, we do. When a die is thrown, either 1 or 2 or 3 or 4 or 5 or 6 will turn up. Now, can we guess which one is exactly going to appear on the top? No, it is impossible to predict which one is going to occur, and therefore throwing a die, six-faced die, can be considered as random experiment. Tossing a coin, then we can say that 2 or 3 cards are drawn from a pack of 52 playing cards. 3 persons are selected out of say 20 persons to form a committee. 3 balls are drawn from a bag containing say 10 balls. So all these are examples of random experiment. Of course, when I say a die is cast, I should say unbiased die, okay? Or a coin is tossed, I have to say a fair coin is tossed. When I say a card is drawn, I have to say it is drawn from a well shuffled pack of cards. Why? Because we should not expect occurrence of one in preference to other. That is very important in probability. Okay. So this was about random experiment. Second definition is outcome. What is outcome? The result of a random experiment is known as an outcome. For example, if we throw a die, getting 3 on the top is an outcome because this is the result of this random experiment. The third definition is of sample space. The set of all possible outcomes of a random experiment is called a sample space, and its elements are denoted by or are called as sample points. A sample space is usually denoted by capital S. Suppose a fair coin is tossed. Then what are the possible outcomes? We know that either head will turn up, I'm sorry, or tail will turn up, provided it is not a surely a coin, and that is why we say a fair coin is tossed. So in this case, what is the sample space? Sample space is nothing but H comma T. H stands for head, T stands for tail. As it is a set, you can say T comma H, one and the same thing. So what is N of S here? N of S is nothing but 2. Now consider the experiment of throwing a die. Then we know that sample space is 1, 2, 3, 4, 5, 6. What is N of S? N of S is nothing but 6. Is that clear? Now when two dice are thrown, then n of s, here I will not write actual elements, but n of s in that case will be what? 6 into 6, that is 36. If three dice are thrown, then what will be n of s? It will be 6 into 6 into 6, that is 216. Okay. We will consider one more experiment. Suppose two balls are drawn out of 7 balls. Then there will be how many sample points? N of s will be 7C2, which is 7 factorial upon 5 factorial into 2 factorial, which is nothing but 21. Is that clear? So there are how many? 21 sample points in the sample space. Then comes definition of an event. This is an interesting part. Any subset of a sample space is called as an event. An event consists of one or more of the outcomes of an experiment, right? In some cases, it does not contain a single element also. For example, when a fair die is thrown, then the sample space, we know that it is 1, 2, 3, 4, 5, 6. Suppose I define event as A equal to, by the way, events are usually denoted by capital letters, 2, 4, 6. How will you define this event? A is the event of getting even score. Suppose B is the event of getting an odd score, then it contains these three sample points, 1, 3, 5. If I say that C is the event of getting either even or odd, then C is nothing but S, sample space. If I define event D as an event of getting a score which is neither even nor odd, then it is a null set, empty set. Is that clear? So this is about an event, and we eventually find probability of an event only. Okay. Yes. Now what are the types of events? The first event, they say it is simple or elementary event. If an event contains only one sample point, then it is called a simple event or an elementary event. For example, consider the experiment of throwing two coins. Then sample space will contain how many sample points? 4. HH, HT, TH and TT. If I say A is the event of getting both heads, then clearly it contains only one sample point, HH. So event A is a simple event. Second, sure event or certain event. An event which contains all the sample points on of the sample space S is called sure event or certain event. The sample space S is a subset of itself, hence it is also an event. This event is called a certain event or a sure event. Why? Because it is sure to occur. Then comes impossible event. If an event is the empty set, that is, it doesn't contain any sample point, then it is called an impossible event. Consider that experiment of throwing a die. If I say again the same logic that the score is neither even nor odd, or if I say A is the event that the number on the top is greater than say 10, clearly it is an empty set, right? So in that case, it is an impossible event. Now complementary event. See, this concept is very, very important because in many cases, instead of considering original event, it is better to consider complementary event, that is complement of that event. Let A be an event in a sample spaces, then A is a subset of S. We can hence think of the complement of A in S. Clearly it is what? S minus A, right? S minus A. This is also a subset of S, and therefore it is also an event in S. This event is called the complementary event of A, and it is denoted either by A dash or A bar. So that is the complementary event of A. I hope you are getting this. Now suppose S contains n sample points and capital A contains m sample points. Then A dash will contain how many? N minus m sample points. Okay, so this is about complementary event. In set theory, we have discussed union, intersection, and so on. So let us revise those concepts because these are useful while discussing probability. Union of two events. Let A and B be any two events of sample spaces. Then union of these two events is denoted by A U B, that is A union B. In some cases, it is denoted by A plus B also. Okay. And how it is defined? It is defined as the occurrence of either A or B or both A and B. So that is union. Second is intersection of two events. Let A and B be any two events of sample spaces. Then intersection of these two events is denoted by A intersection B or by simply AB. And how it is defined? It is defined as the simultaneous occurrence of both the events A and B. The third one is important. Mutually exclusive events. If simultaneous occurrence is impossible, simultaneous occurrence of two or more events is not possible, then events are said to be mutually exclusive events. So if A and B are disjoint, that is, there is not a single common element, that is, A intersection B does not contain any sample point, then we say that events are mutually exclusive. Is that clear? The fourth term is also important. You must have heard about this word, exhaustive events. If all the possibilities are taken into consideration, that is exhaustive. Suppose A and B are two events in a sample space S, and if A union B is sample space itself, then A and B are said to be exhaustive events. Now you will appreciate this. Suppose A and A dash are two events on the sample space. If A is an event, of course, A dash will be an event. Can you tell me what is A intersection A dash? It is null set phi. And what is A union A dash? It is nothing but sample space. So can I say A and A dash, these two events are both mutually exclusive, at the same time exhaustive. Is that clear? Yes. So this was about the basic things. While solving probability, we are required to discuss events or experiments related to cards. So you should know basic things about playing cards. So this is about playing cards. There are 52 cards in all. You're not supposed to include jokers. Out of 52 cards, 26 are red. 26 red cards include 13 hearts and 13 diamonds. 26 black cards include 13 spades and 13 clubs. Now there are 4 suits: heart suit, diamond suit, spade and club. 13 cards in each. Okay. There are 4 aces. An ace means number 1. There are 12 face cards, FACE. Face card is also called as picture card. Which 12 face cards? 4 jacks, 4 queens and 4 kings. Okay. So there are how many? 12 picture cards, that is face cards. So you should know this much about playing cards. Now we discuss and define probability. See, when a triangle is given, then without actually knowing 3 angles, we can say that sum of measures of all angles is definitely 180 degrees, right? But when I say a die is thrown, can I confidently say which number is going to occur? No, right? So clearly here degree of uncertainty is there. Now it is possible to express numerically this uncertainty due to chance. Thus, in case of normal coin, head and tail have equal chance of occurrence. In case of throwing a die, all the 6 numbers have equal chances of turning up, right? We have already discussed this. We have termed them as what? Random experiments. Now, before I actually define what is probability, we must discuss the concept of equally likely outcomes. Two outcomes are said to be equally likely if either of them cannot be expected to occur in preference to the other. That is, when a coin is tossed, then head or tail are equally likely. That is, chance of getting head is the same as chance of getting tail. And that is why actually this is repetition. In the beginning only I have explained this. That is why they use word a fair coin is tossed, unbiased die is thrown, well shuffled pack of 52 playing cards, 3 students are solving a problem independently, etc. Okay. Now we define probability of an event. Let A be an event in a sample spaces. Then the probability of the event A is denoted by P of A. Is denoted by what? P of A. And how it is defined? P of A is defined as number of sample points in A upon number of sample points in S. Now numerator is n of A as per notation, cardinal numbers. And what about denominator? It is n of S. So you have to remember that what is P of A? P of A is nothing but n of A upon n of S. Usually this number is denoted by m and this is denoted by n. So what is P of A? It is m upon n. Now clearly, probability has to lie between 0 and 1. Of course, both values inclusive. That is, we can say that if A is an event of a sample space S, then 0 less than or equal to P of A less than or equal to 1. And what is P of A dash, where A dash is the complement of an event A? It is 1 minus P of A. Okay. Now let us prove this part. Proof is not at all difficult. See, we have defined P of A as what? M upon N. N of A upon N of S. So clearly 0 less than or equal to M less than or equal to N. I divide throughout by N. So 0 less than or equal to M upon N less than or equal to 1. That is I can say 0 less than or equal to P of A less than or equal to 1. Is that clear? So probability is never greater than 1. Probability is never negative. Probability of an impossible event is 0. For example, what is the probability that student from our class will fail in the exam? 0, because it is an impossible event. If probability of an event is 1, it is called as certain event, sure event, and vice versa. For example, what is the probability that student of our class will score good marks? 1, because this is certain event. Okay. Now many times we say I'm 110% sure. Actually in saying this, at least in saying this, we are 100% wrong. Why? Because we say out of 100, favorable are 110. So probability is 1.1. Wrong. Probability can never be greater than 1. Is that clear? Now what is complement A dash? See, out of n, m are in favor of A dash. Okay. So can I say P of A dash equal to n minus m upon n. Why? See, denominator indicates total number of sample points in the sample space. M are in favor of A. So remaining, that is n minus m, will favor A dash. Split numerator. So it is 1 minus m upon n. But what is m upon n? It is nothing but P of A. Right? So P of A dash is nothing but 1 minus P of A. I hope you are getting this. Right? So this is about the initial part of probability. Now we are in a position to solve sums from the first exercise. Exercise 9.1, first sum. There are 4 pens, red, green, blue and purple in a desk drawer rather, of which 2 are selected at random, one after the other with replacement. You have to read the sum carefully. State the sample space and the following events. A. Selecting at least one red pen. B. 2 pens of the same colors are not selected. Now we denote red, green, blue and purple by R, G, B, P respectively. See, you have to read the problem carefully with replacement. So if the first ball is red, it is again replaced. So second ball can be red, green, blue or purple. The first is red only. Now next 4 cases, first ball is green. So second can be green, red, blue or purple. Suppose the first is blue, second can be blue, red, green or purple. If the first ball is purple, second can be purple, red, green or blue. So in all, how many? This is not asked, but I have written n of s is 16. Now it is event A, that at least one red pen is selected. Now at least one means one or more. So here RR, RG, RB, RP, GR, BR, PR. So these many are in favor of event A. B is the event that 2 pens of same color are not chosen, selected. So the set consists of RG, RB, RP, GR, GB, GP, BR, BG, BP, PR, PG, PB. Second sum, a coin and a die are tossed simultaneously. Enumerate the sample space and the following events. Okay. Now when a coin and die are tossed simultaneously, what will be the sample space? H1. Actually, you can write H1 without giving comma. So in that case, you need not write this in a circular bracket, right? But if you want to use circular bracket, means an ordered pair. So H comma 1, H comma 2 up to H comma 6. Now it can be tail also. So T comma 1 up to T comma 6. So 12 points are in favor of the event. Rather, 12 points are there in the sample space. Now A is the event that tail and an odd number. Now out of 6, 3 are odd and it should be tail. So T1, T3, T5. B is the event of getting prime. Remember, 1 is not a prime number. The first and the only even prime number is 2. So H2, H3, H5, nothing is said about head or tail. So H2, H3, H5 or T2, T3, T5. C is the event of getting a head and a perfect square. So H1, H4. That's it. That's it for today.